Friends, welcome to my YouTube channels. Today I am going to discuss slope and deflections of a simply supported beam with a UDL in the entire span. That means A to B is beam and entire beam we have UDL. So we have to derive what is the slope and what is the deflection. That is called maximum slope and maximum deflections we have to derive. So here all boundary conditions I wrote. You see, if due to the UDL, deflections will start from point A. So from point A, deflections will be 0. Why is deflection? So deflections will be 0 when x equal to 0. In this point x equal to 0, that means distance. Then deflection also. Deflections gradually will increase and middle of the point deflections will be maximum. When x equal to L by 2, deflections will be maximum. Y will be maximum. And regarding the slope will be maximum at point A and at point B. When x equal to 0, slope will be maximum. Y equal to 0, slope will be maximum. And slope will be 0 when x equal to L by 2. How will know the slope? This, suppose due to the deflection, this dotted line is deflection. If we draw the tangent line, this angle is known as deflection. This is known as slope, not deflection. And this angle also known as slope. But here slope will be 0. Why? Because if you draw the curve line of tangent, these two angles will be 0. So when x equal to L, your slope will be 0. When x equal to 0, slope will be maximum. This is the boundary conditions. When once we'll derive this, that time we'll use this boundary condition. So before this, what we have to do, how to start? First we'll find, because this is simply supported beam. So we have find the support reactions. Already I wrote, but how to find the support reaction, that also we have to write here. So we know the equilibrium equation, sigma F equal to 0. Sigma F equal to 0. So under this what we are discussing? Total upward force equal to total downward force. Total upward force equal to downward force. What is upward force here? RA plus RB equal to downward force. What is? W into L. W into L. Because this is UDL per unit length. So what will be the load? W into L. Now second equilibrium equations will take moment about A equal to 0. So here he will take clockwise moment is equal to anti-clockwise moment. Under this what will write? If we will take moment about A, so due to this UDL, it will come clockwise. So what will be the W into L load, then L by 2 half distance into L by 2 is equal to RB into L. So how this coming? UDL, already so many times we discussed. Suppose this is UDL will be there. If we will find the moment about A, per unit length is there, okay? This length is L. If you draw the load diagram, so middle point will be the load will act. Why? Because deflection is middle point. Maximum deflection is middle. So that means load is acting in middle. So this load will be W into L. Then this distance is L by 2, this distance will be L by 2. Now we'll take moment about A. So what will come? Moment about A. This will coming clockwise. Clockwise what is? W into L by 2. WL into L by 2. Then RB. This will rotate anti-clockwise. So RB, this is RA suppose, RB into L. So RB into L I wrote. So this way we can find the moment. Okay. So now RA and RB value we'll find out. So what is RA and RB value? So here L get cancelled. So what will come here? RB is equal to WL by 2. Then if you substitute here WL minus WL by 2, it will come WL by 2 only. So RA will come again WL by 2 what I wrote here. So both support reactions, we know the support reaction WL by 2, WL by 2. Now we'll take bending moment at point XX. We'll take the bending moment at point XX. So moment is nothing but force into perpendicular distance. Now suppose we will take x. So this point, what will come? Ra. So I am writing bending moment at point xx. What will write here? Ra into x minus, this is what is w into x by 2. This is the bending moment at xx. So finally what we can write here? Rm is wl by 2x minus wx square by 2. So this all, what w we are writing now, this w is the small w only, small w, because per unit length. Okay, these are the small w. So what is this bending moment we got here? Bending moment at xx, what, wl by 2x minus wx square by 2. Okay, wl by 2x minus wx square by 2. Now to calculate the slope and deflection, to calculate slope and deflections, we know the slope and deflections, we will write the bending moment equation. So we need bending moment equation. So bending moment equation is m is equal to ei d square y by dx square. What is this one? This is the bending moment equation. How this bending moment equations came? Previous video already explained by the radius of curvature and all. So each video we cannot explain. So some video like deflection of beam, first video we already explained how this coming bending moment equations. Now this bending moment equations will equate both sides. So what is this our bending moment equations here? So we'll write here ei d square y by dx square is equal to, this bending moment equations will write here, what is wl by 2x minus wx square by 2. I wrote this. Now if we will integrate this, we will get the slope here. So we'll check once we'll check what we wrote here. Bending moment equations we got at xx point, and bending moment equations we know m is equal to ei d square y by dx square. Now we substituted this value wl by 2x wx by 2. Now what we'll do? Integrating both sides. So we'll integrate ei is constant, that implies d square y by dx square is equal to wl by 2, you take outside, integrate x dx minus w by to take outside x square dx. This is the integrating both sides symbol given. Now we'll integrate. What will be the integrations? See here, ei dy by dx will be here. How this coming? See here, this we can write d by dy and dy by dx. We can write this because both will be same, d square y by dx square. This is integration, this is differentiation. So integration differentiation are always inversely proportional. That means this is the our integrations dy by dx equal to wl by 2 x square by 2 integration minus w by 2 x cube by 3 plus some constant gives c1. This is the integrations. This is the integrations we got. What is ei dy by dx, wl by 2 into x square by 2 x dx integration, then w by 2 I taken constant, x square definition is x cube by 3 and given some constant c1, because this is indefinite integration. Indefinite integrations means we have to give the constant. Now this constant how will eliminate? By using the boundary condition, we will eliminate the constant, then we will get this slope equations will get. So now dy by dx will be 0 if dy by dx, that is slope will be 0 when x equal to L by 2. If when x equal to, right here, when x equal to L by 2, then dy by dx will be 0. That means slope, you see slope is maximum. Here slope, if you draw the tangent in the curve, slope will be 0. So dy by dx will be 0. So we'll substitute now this value here. So that implies what will come? This will get ei, then this is 0. Now x equal to L by 2. So this is WL by 4. Then x square means L square by 4. L square by 4 minus, what will get here? W by 6. dy by dx you write here, consume. dy by dx equal to 0. Okay. So w by 3 to the 6. X cube na L cube by 8 plus C1. We got, see this substituted value na, we got this is W L by 4, L square by 4 minus W by 6, L cube by 8 plus C1. If we'll solve this, C1 value will come, C1 value will come minus W L cube by 24. This is the C1 we got here. So this is, we got the C1 here. This is the C1 I got. Substitute C1 in equation 1. We'll give the equation number 1. Now substitute C1 in equation number WL cube by 24. We'll substitute now. Equation, not equation 1 here. Equations 1 will be here. This is the equation 1. Substitute C1 in equation 1. Substitute C1 in equations 1. So equation 1 becomes, so what will be the equation 1? Ei dy by dx as it is, this you write as it is, WL by 4 you write, WL by 4 x square minus W by 6 x cube minus WL cube by 24. So this is nothing but slope equation. This is nothing but, you can write, this is nothing but slope. This is nothing but slope equation. Now, this we got the slope equation. Now, maximum slope. When will be the maximum slope? That means theta A, theta B. Slope will be maximum when x equal to 0. If put x equal to 0, we'll get the maximum slope. So now we'll write, to get maximum slope, put x equal to 0. See, x equal to 0, slope is maximum. So what will come this equation? So we'll write here somewhere. Here we'll write this. What we'll write here? So when slope will be maximum, to get the maximum slope, put x equal to 0. So now what will come? Ei dy by dx maximum, then put x equal to 0 na, 0 minus WL cube by 24. So finally what will come? Dy by dx maximum, that is slope is maximum, is known as WL cube by 24. This is nothing but theta A maximum or theta B maximum. This is called slope. So what is this value we got here? Maximum slope we got minus WL cube by, we got the minus WL cube by 24. Then here what we have to write? Because this EI is there, na? So this EI will come here. 24 EI. E is young modulus, I is modulus, I is moment of inertia. So this is the maximum slope we know now. Maximum slope we know. Okay. WL cube 24 EI. Okay. Okay. Now we have to differentiate again, and we'll go to the deflection. So we'll start from here. So now this part will rub it. Which one we have to integrate? Integrate this one. So it will give the equation number something. Okay. Now this is the slope equation now. Slope equations, we give the equation number 2. This slope equation give the equation number 2. Now integrate the equation 2 or slope equations again. So we'll get the deflection equation. We'll get the deflection equations. Okay. So again, right here. Again, integrate equations 2. So we'll get what we'll get. See here. EI integrate dy by dx is equal to WL square by 4 integration of x square dx minus W by 6 x cube dx, x cube dx, then minus WL square by 24 dx. This continuously there, or again I'll write, just should be one line, now it will be good, it will looks good. Okay. So slope equations now I will write here again. EI integrations dy by dx equal to WL by 4 x square dx minus W by 6 x cube dx minus WL square by 24 dx. So we'll integrate. What is the integrations now? This integrations will come y. EI, this is y. dy by dx, it will come y. So see here, d by dy dx, dy dx and y. So same thing, this and this will cancel, this will be y. Okay. So integrations will be dy integrations will be y equal to WL by 4 x cube by 3 minus W by 6 x 4 by 4 minus WL square by 24 x plus some constant C2. Some constant C2. Now we'll get C2. So how we'll get C2? Again we'll apply the boundary conditions. Again we'll apply the boundary conditions. So WL by 4 x cube by 3 minus W by 6 constant x cube integration x power 4 by 4 minus W L cube. So here this WL cube is there, no? WL cube. WL cube. So this as it is WL cube. Then x dx integration is x. So this our equation says WL cube by 24 C2. Now how to remove the C2? So what we have to do, this deflections will be 0 when x equal to 0. So deflections y is equal to 0 when x equal to 0, because deflections will be 0 at the point A. So what will get these equations now? Now this will rub it here up to this C1, then enough space will be enough for us. So Now what we'll do? Y is equal to 0. So EI 0 is equal to x equal to 0. So what we'll get here? Everything is x. So 0 minus 0 minus 0 plus C2. So C2 will get 0. So C2 will get 0. Substitute the C2 in equations, give the equations number 3. Substitute the equations number 3. Give the equations number 3. So substitute C2 in equations number 3. Substitute C2 in equation 3. So what we will get here now? EIY equal to same thing here, WL by 4 x cube by 3 minus W by 24. This you can write also 12, no issue. X4 minus WL by 4 W x cube correct by 4 into 3 24 x4, okay, WL cube by 24 x, so C2 is equal to 0. So this equations we got. What equation this is? This is the deflection equation. This is slope equation. This equation is known as deflection equation. This equation is known as deflection equation. So what is deflection equations we got? EIY WL by 4. So 12, 4 into 3, 12, x cube, W by 24, x4, then WL cube by 24x. This is called deflection equations. Now, how to get the maximum deflection? If deflections will be maximum, that length will be x equal to L by 2. So, when deflections will be maximum, y will get y max when x equal to L by 2. So, y is equal to y max when? This y maximum when will get? When x equal to L by 2. So, we will substitute this, then we will get the equations we will get the equation here. EI y max is equal to what is? WL by 12, L by 2. So, x L cube by 8 minus W by 24, L 4 by 16, 4 ja, minus WL cube by 24 into L by 2. So this we got here. Now these equations will remove here. Then we'll get the final. So if this will solve, so everywhere we substituted value. Check it once, because here WL by 12, L cube by 8, WL power 4, 24, 16, WL cube by 24, L by 2. If you will solve this, how much you will get? Minus 5W L power 4, L power 4 divided by 384. 384. This will get what is? Y maximum, then EI. Because this EI will bring here. So this is the equations of the maximum deflection. This is the equations of the maximum deflection. So maximum deflection, how much we got? Minus 5 WL power 4 384 EI. So if we'll take, how we are getting this now? We have to take the LCM 96, 384 and 48. If we'll take the LCM, you will get this value. So this is the maximum deflections we got. Now what is W? If we'll take W total load, then total load is equal to nothing but W into L. Suppose sometimes problem they will give total load given. Then this is W nothing but what is? Per unit length. But this load W into L will be capital W. If you will substitute here now, what will get here? You will get minus 5 capital W L cube by 384 EI. When you will substitute the total, here W is total load. Here UDL load. W is UDL load. So this way we can calculate we can derive the slope and deflections of a simply supported beam with UDL for the entire span. Okay. Okay, students. Thank you. Watch the video. Subscribe the channels. Okay.